Video is for this topic is you should know the basics of linked list. What is linked list, how to represent a linked list, or you should know the what is singly linked list. Basically when we say linked list, then we are talking about singly linked list, right? So we are going to implement singly linked list here. Fine. Plus you should know what is dynamic memory allocation and how to use the malloc function in C language, right? As well as you should have the knowledge of pointers plus structure. What is structure data type in C language, how to access the structure members, right, using that structure variable also plus pointer also. Fine. So now first of all we will see the logical view of a linked list. I am going to create a linked list here. I am just going to draw a linked list here having 3 nodes only. So this is, you can see, a logical view of a linked list having 3 nodes. This complete is known as a node. What is a linked list? How to represent this? I have already discussed. I will provide you the link of that video in the side button. You can check out there. In the last node, in the address part, see 2 parts of a node are there. This one is data part. This part of the node is going to store actual data, and this part is going to store address of next node. Right, that is why here I am going to store 200, here I am going to store 300. 100, 200, 300 are random addresses. These addresses are in hexadecimal form. This is just for your understanding purpose. So see, in the last node, address part is going to contain 0 because it is not going to point any node further, right? So it means it is having null. Fine. This is just a logical representation of linked list. Now how we are going to map this logical view in programming, how to write a C program, right? Initially we don't have any node, fine, and this is what a head pointer. Head pointer is going to store address of first node. Always we are going to have in program, when you are writing a program, in that case you have to maintain what? This head pointer. Now see, first of all, we don't have any node in the linked list, right, and we are going to create a linked list having 3 nodes. We are going to create this one, and after that we are going to display the content of the nodes, that is 5, 4 and 9, right? We are going to see that in coding. So now first of all we have to create a node, fine. Now how to create a node using a user defined data type, that is structure, that we have already discussed. Now how to write down that thing? See, we are going to write struct keyword, then this tag, that is node. This complete is what? Now a data type. You are going to define your own data type, fine. Data type of this node. Now this node is going to contain 2 parts. One is this integer part, and this one is what? Is going to contain address, and for address we are going to take what? Pointer variable always. So first part would be int, suppose we are going to take data or a or b or number, as you can as you wish. Fine. Now next is for pointer, this pointer. Now the data type should be, this pointer is going to store address of next node, fine, and the type of this is what? Struct node. So that is why I am going to write here struct node asterisk, and suppose the pointer name is next. You can say link or as you wish, fine. So now this is what you have just defined your data type. It's not that you have created this node. No, not now. The memory has not been allocated. This is just what? You have defined your own data type, right? That is a struct node, fine. Now what you will do? You have to maintain this head node also, because this is what the main thing. This is going to have the address of first node, then you can traverse the list. So this is the main thing. So now you have to, this is what? A head pointer, because it is going to store address of this node, fine. So how to declare this pointer? See, we will write what? Struct node asterisk, and suppose the pointer name I am going to take head. Why I am writing this struct node here? Because see, here you will write what? Always you will write, if you write int star p, it means this pointer is going to store address of integer variable, right? This is pointer to int. So this is what? This pointer, head pointer, is going to store address of a node, and the data type of this node is what? Struct node. So here we always write down the data type of that variable or that thing whose address this pointer is going to store, fine. So in C language we are going to write struct node. If you don't write, don't use type def, fine. In C++ you can simply write this node, that is fine, but here I am discussing C language. Fine. Now we have created this head node. Initially, suppose we don't have any node in the list. So initially what head pointer will store? Head is going to contain what? 0, or you can say null. Now we are going to create a node. Fine. Now you will write something such that memory is to be allocated for this node. So now here we are going to use what? Dynamic memory allocation, that is malloc function. In C language you are going to use malloc function. In C++ you can use new keyword. Fine. Now how you can use malloc function? See, the syntax is what? You simply write malloc, and in bracket you will write what? The size, how much memory you want, right? So how much memory we want here? The size of this, according to the size of this node. Fine. So here you will write size of, and in bracket you will write what? See, data type of this node is what? Struct node. So here you will write data type, that is struct node. Fine. So how much memory is to be allocated? Size of struct node. Size of struct node. The data type is struct node. In this struct node we are having one variable data that is of integer type, that is 4 bytes, and one is pointer. In 32-bit compiler 4 bytes is to be allocated. In 64 8 bytes. So 4 plus 4, that is 8 bytes. Complete block of 8 bytes would be allocated dynamically. Now see, this malloc is what? What it is going to return? Malloc is a method or a function which is going to return a pointer to the starting address of that memory block, because memory block of 8 bytes has been allocated. Fine. So it is going to return a pointer to the starting address of that memory block. Fine. So malloc is going to return what? Pointer, or you can say it is going to return a void pointer. So now what this malloc is going to return? See, it is going to create a node in the memory, a block of how many bytes? 8 bytes, right? Here 4 for this and 4 for this, and suppose address of this is 100 I am going to take. See, this complete block is having how many bytes? 8 bytes, and the address of first byte is what? 100. So that is why I am taking what? Address is 100. So it is going to return what? 100. Address, starting address of this block. Now we are going to store this 100. This is the address, so we need what? A pointer variable to store this. Fine. So we have to create one another pointer variable, that is, here we are going to create asterisk new node. This is what? Another pointer variable. One is head and one is what? We are going to take new node. Whenever we are going to create a new node, we are going to take this one. The address of that node we are going to store in this pointer variable. Fine, because malloc is always going to return what? Pointer to the starting address, and it is going to return what? Void pointer. See, this new node, you can say here we are going to take, this is what? New node. This is just a pointer. Now whatever the address the malloc function is going to return, we are going to store that address into this new node pointer, that is pointer to node, but it is going to return what? Void pointer. So you have to typecast this one. Fine. So for typecasting, here you will write what? Struct node asterisk, because we are dealing with a pointer to node. Fine. And the address we are going to store in new node. Address, the type is this. This is what? A pointer to node. So the type is what? Struct node asterisk. Fine. So now this is how we are going to dynamically allocate the memory. Now this block has been allocated of 8 bytes, and in new node now we have 100. So it is going to point here. So now we have created a node, but we don't have any data here. So you can ask from the user for the data, and for how you will write? Using scanf you are going to take the input from the user. So the data type is int, so we are going to use %d. And now see, you cannot directly write here hash this address of and data. We cannot directly access the members of this structure. Fine. If we are accessing the members of the structure using what? Using this pointer, then what is that syntax? Address of, see, using this pointer variable we are going to access this node. Fine, because we have just the address of this node. So how you will write the pointer name, new node, then you will write what? This arrow symbol, and now you will write that name of that variable, the name of that structure member, that is data. This is how you can access the members of a structure using pointer. Fine. Using dot operator you can also use, but here I am using this arrow method because this is what easy to use. Now see, suppose user has entered what? This 5. So here you will write what? 5. And in this here, now we have only one node, so here you can insert what? Null or 0. So here you can insert 0. So here you can write what? This new node, arrow operator, and for this part, this is what? The pointer name is next. So here you can write next is equal to 0. So this is how we are going to access the structure member. See, this address part also we can access using this pointer. So we are going to use the name of that pointer, then arrow operator, and then the name of this part is what? We have taken what? Next for this part. So next is equal to 0. Now see, now we have created this node, we have inserted the data. Now we are going to put this node in the linked list. Fine. Initially see what we have done, head is equal to 0. See, initially you can say here we have head and it is going to contain 0. Now next thing is you have to point this to this. Fine. So now you have to store this address into this head. Fine. Now how we are going to store this address is there what? In this pointer, that is in new node. So simply you can write head is equal to new node. So here now 100 is there and this is also going to point here now. New node is also here and head is also here. So now the list is having only one node, that is this one, and head is going to contain address of this. So how we can write this? Head is equal to new node. So simply here you can write head is equal to new node. Fine. This 100 would be stored here and this is going to point here now. Fine. Now suppose you are going to insert one and you are going to create another node and you are going to insert here. Fine. In that case head is not null. See, in this case, at starting case, head is equal to null. That is why we have simply done this thing. If head is equal to not null, then what you will do? So here you will write one condition before this. If head is equal to null, then you can do this thing, then that is fine. Else if head is equal to not null, then what you will do? Now suppose we have created one more node using this code also. Fine, we are going to write down that thing also, how this program is going to run again and again, how this code is going to run again and again. See, suppose again this line is going to execute, new node is equal to this thing, then in that case again one node is going to create it. Fine. And suppose address is now 200. So now 200 is now going to assign in this new node. So now in this new node we have what? 200. So this is now not going to point here now. Now suppose this is our new node and this is now going to point here because we have created one more node now. Now we are going to enter the data. Now suppose 4 we have entered, 4 is going to store here, and in the next part here we are going to store what? 0. Right. So now we have created one more node and we are going to insert this node in the list also, because here we have only one node in the list, head and this one. So here we are going to store this new node. So you have to update the pointers. Now in this case head is equal to not null, head is having 100, the address of the first node. So this we cannot do now. Fine. If you don't write this condition and you simply write head is equal to new node, then in this case also now head is going to contain head is equal to new node. So head is going to contain now 200. Fine. So this link is going to be destroyed and now head is going to point here. But that thing we don't want. Fine. Because we are going to insert this now here. So you cannot destroy this link. So simply you cannot write this thing. That is why we are going to write this condition. If head is equal to null, then you can write this thing, then it is right. If head is equal to not null, then what you will do now? See. So now to insert this newly created node here in the list, what you will have to update? we are going to store address of this newly created node here, that is 200 here. It means now this is now going to point what? Here. Fine. So in the list we have this one and this one, 2 node. Fine. So simply how you can access this part, this structure, because this node is having data type structure, so you cannot simply access this one. How you can access? Using arrow operator. Fine. Using pointer. The pointer of this node is what? Head pointer. So you can write here head, this arrow operator. In C, when you are writing a program, then you can simply write hyphen and that angular bracket. Fine. And the name of this pointer is what? Next. Next is equal to what? Here you are going to store 200, that is whatever is in the new node is equal to new node. So now we are thinking that this is now done. Fine. Now list is having these 2 nodes. Fine. Now the problem comes when you are going to create one third node. Now suppose the program has been executed again and another node has been created, this one. When this line is to be executed, another node has to be created. Suppose address is 300 and in this we have suppose 9 and here we have 0. And now the new node is going to contain 300. So now the new node is going to contain 300. So this is now going to point here now, right? We have inserted the data and this also we have initialized 0. Now if head is equal to 0 but head is not 0, then we are going to here into else part. Now how we are going to insert this newly created node here after this? Now in else node, whatever you have written, see, head of next is equal to new node. Now head of next is what? This one, because this head pointer is having 100, so we can access this. This is pointer to this node. So head next means this one. So now here we are going to store new node. The new node is going to contain 300. So here we can insert now. According to this, we are going to insert 300. So that is why this link has been destroyed and now this is going to point here. But this is not actually done because this is first, second, then, and after that we are going to insert this third node. But according to this coding, we have lost the link to this node. Now this node is not in the list. So now this you cannot write. So the solution of this problem is what? You have to take one extra another pointer. Here we are going to take one pointer, that is temp, one more pointer. Now see, what is the role of this temp? See, we cannot move this head pointer. We cannot change this value of this head pointer, because if you are going to change this value, then you will lose the link or reference to this first node. That we cannot afford. So we cannot change the value of this head node. This is going to be permanent. Fine. Now this temp, this pointer, this value you can change. Suppose at first temp is going to point here. Next it is going to point here. Next it is going to point here. So you cannot you change the value of this temp pointer. When you are going to traverse the list, then we are going to traverse using this temp only, because we cannot change this head value. See, this new node pointer is what? It is just going to contain the address or the pointer to the newly created node. Fine. And head node is going to contain head pointer is going to contain address of first node. Fine. So for traversing the list, obviously we need one extra pointer. We cannot change this head node. We cannot use this new node pointer because this is only going to have address of newly created node. That is, we are going to create this. We are going to take another pointer, that is temp. Fine. Now you have to modify your coding a little bit. See, here you cannot write this line. Here what you will write? Temp of next is equal to new node, right? And here at starting, if head is equal to 0, head is equal to new node, as well as we are going to initialize this temp. Temp is also going to point here. So head is equal to temp is equal to new node, right? So now head is also going to point here, plus one extra temp is also there, extra pointer is also there, another pointer temp is also going to contain new node, that is 100. Now temp is also pointing to first node, both head and temp. We cannot move this head, we can move this temp now, right? Now here we can write temp of next, because this node is having two pointers, this one, so you can access this node using this temp pointer. So temp of next is equal to new node, that is 200. Fine, when we were inserting this second node. Fine, plus what you will write here, temp is equal to new node. Now we are going to move this temp is equal to new node. At this time temp was 200, right? When we were creating this second node, that is here. So now temp is going to contain 200, right? So now temp is going to point here. Fine, and new node is also having 200. Now when you are going to create this third node, suppose you have created this third node, now new node is going to contain 300 when the third node is going to create, because new node is equal to this one. So now new node is going to point here. This is now our newly created node, right? So how you can insert this node here after this node? See, now you can see this line is correct. If head is equal to null, this condition is not true, right? So in else part you will write temp of next is equal to new node. Now temp is having 200, so using this temp you can access both the parts of this node, right? So temp of next means this one. So here you will write new node, value of new node is 300, so here you will insert 300. So now it is going to point here to the newly created node. Fine, so this is fine now. First node, second node and third node, right? That is why we are taking this third pointer variable. I hope now you have the idea why we are taking these 3 pointers. Now we are going to move this temp. Fine, now temp is going to have this new node, that is 300, value is now 300. Now temp is not going to point here. Now temp is going to point where? To this one, to the third node in the list. Fine, and if we create another node, obviously simply now temp next means here you can insert the address of newly created node. Fine, so this is now the proper logic. This is how you will write this. So now we have created these 3 nodes. So I am going to rub this thing now. So now this is our list. Temp is pointing here, new node is also pointing here, and head is pointing here. Now see, now you want to implement a program something like this. You want to ask from the user, do you want to continue? If user press 1, then you are going to create another node. Fine, again this code is going to run. If user press 0, it means you are not going to create another node. Now you are going to print these values. Fine, so for that what you will write after this, what you will write, you will ask from the user printf, do you want to continue? For taking input you are using scanf %d address of. Now suppose we are going to take one variable choice, and here we are going to store the choice of the user, either 0 or 1. 0 means we are not going to continue, 1 means he wants to continue, he wants to create another node. Now you have to declare this choice variable also. So here you can declare int choice, right? Now if user press 1, it means again this code is going to run. Fine, so now we have to write this code into while loop. Fine, so where you will write this while loop? Here, before this new node, because if user press 1, then another node is to be created. It means that another node is to be created using this line. So before this line you will write while, and in bracket you will write choice. So after this line int choice, and before this line in the program you will write while choice. I don't have enough space, that is why I am writing here something like this. Fine, while choice, and you will this bracket, and after this bracket you will write this line, new code is equal to this one. So now this while loop you are going to close here. Now using this code you can create as many nodes as you want. Now next thing is you want to print, you want to traverse the list. How you are going to traverse? from here, first of all, or you can say you are going to print the values 5, then this 4, then this 9. We cannot move this head pointer, so that is why again now at last temp was here, so again we are going to initialize this temp from here, right? So in temp, first of all you are going to store temp is equal to head. Now in temp we are having 100, so now temp is pointing here. So now you are going to print 5, 4 and 9. So here you will write a while loop, while temp not equal to null. Fine. Till then you are going to run this loop and you will print this value that is data. So now we cannot directly print this 5. You cannot directly access this data. You can access this member of the structure using this pointer. Fine. So now you are going to print this 5. So simply you will write printf. After that you will write temp, this temp, arrow operator, and name is what? Data. Name of this variable is what? Data. Now this is going to point 5. This is now going to print this 5, right? Now we are going to print this 4, but we cannot directly print this 4. Fine. So we are going to move temp now here, right? So now temp is equal to temp next. See, temp of next, the value is going to store in temp next. Temp is what? 100. So temp is going to point here. Temp next means 200. So now 200 is going to store in temp. So here you will store now 200. Now this is going to point here, right? Again condition, while temp is equal to not null. Temp is now 200, so it is not null. So now print temp data, means temp data, that is 4. It is going to print now 4. Again temp of next. Temp of next is 300. So now 300 is going to store in temp, that is here you will store 300. So now temp is going to point here. So now temp is not null. Yes, temp is not null. Condition is true. Now again print temp of data, that is 9 would be printed. First 5, then 4, then 9 would be printed. Now temp of next. Temp of next means 0. 0 would be assigned here, temp. Now temp is going to contain 0. So now while temp not equal to null, now this condition is not true. Now we are not going to print here because now temp is what? Null. Temp is 0. So now simply you are going to exit. So here you can write get ch, and this code you are going to write in void main function. Fine. Or you can simply create a function of create, node or display. Fine. And you can write down this coding into those functions and you can call those functions into this main function, or you can directly write down this coding in the main function. And if you want to print how many nodes are there in the list, then you can take a simple variable that is count. You can declare here int choice and int count, and in this while loop you can write down one more step, that is count plus plus. You can initialize the count at starting. Int count is equal to 0. Fine. Here only. And here count plus plus, and after this while loop you can print this count value, printf %d and count. So this 3 would be printed because here in this case we have 3 nodes. So this is how you can create node and traverse the list. I hope you got the concept. In next video we will discuss how to insert newly created node in the list at beginning also, at any position also, and at end of the list. Fine. So I'll see you in the next video. Till then, bye bye. Take care.